Hello and welcome to the Data Engineering Podcast, the show about modern data management. Atlan is the metadata hub for your data ecosystem. Instead of locking your metadata into a new silo, unleash its transformative potential with Atlan's active metadata capabilities. Push information about data freshness and quality to your business intelligence, automatically scale up and down your warehouse based on usage patterns, and let the bots answer those questions in Slack so that the humans can focus on delivering real value. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, to learn more about how Atlan's active metadata platform is helping pioneering data teams like Postman, Plaid, WeWork, and Unilever achieve extraordinary things with metadata. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. This week is a special crossover episode from our other show, The Machine Learning Podcast. If you like what you hear, then you can find more at themachinelearningpodcast.com. Your host is Tobias Macey, and today I'm interviewing Frank Liu about how to use vector embeddings in your ML projects and how Towhee can reduce the effort involved. So Frank, can you start by introducing yourself?
Hey, Tobias. First of all, thanks for having me on the show. Yeah, my name is Frank. I'm currently a director of operations as well as a machine learning architect at Zilliz. And we're a startup that does vector database as well as the greater vector database ecosystem.
And do you remember how you first got involved in machine learning?
Yeah, no, absolutely. Right out of grad school, I actually went to work at Yahoo, and it was a great opportunity for me to really be immersed in not just computer vision, but the broader machine learning world as well. Specifically, I was on the computer vision and machine learning team over there. For the better part of 2 years, back then it was 2014, 2015, it was still very much the Wild West days of AI, of ML, really trying to figure out how do we use machine learning in production systems. Back then, there really wasn't a solid concept of what MLOps was. People really were still trying to figure out how to productionize their machine learning models. One of the ways that we did it, and it's really funny, was we would actually just put all of our models, and we were using Cafe back then, we just put all of our models into a Docker container, and then we would give this container to whichever folks needed to use it. That's definitely not what most folks would do today or would think about how they productionize a machine learning model or a machine learning pipeline, right? Going back to your original question, that's really where I got my start into machine learning and in AI in general. I've been, in or adjacent to this area, I want to say for the better part of 7 or 8 years at this point. And it's been amazing seeing the growth, not just in the capabilities of models these days, from your very first AlexNet computer vision to LSTMs. Now we have transformer-based models. Diffusion models are really taking the world by storm. But also the growth, I think, that we've seen in a lot of the infrastructure around machine learning as well. So, there's AWS, SageMaker, for example, and a lot of these other MLOps startups, a lot of these machine learning startups that really help you make the most out of your machine learning models or out of your AI algorithms. And I think it's amazing to see the growth in just, I want to say, 5 to 10 years in this industry in general.
One thing I just want to comment on is that it's funny how working in technology, you say way back when, and then you're expecting for somebody to say, reference something that happened maybe 20, 30, 50 years ago, and it's, 5 to 7 years ago, which is humorous in one context, but it's also just a good indicator of how fast the industry is moving.
Absolutely. Absolutely.
And so in terms of the project that we're discussing today, Towhee, I'm wondering if you can describe a bit about what it is and some of the story behind how it came to be and the particular problem that it's aimed at solving.
It probably makes sense to start with our vector database itself. We are the primary driving force behind a sister project of Towhee, a much more mature project called Milvus. And Milvus is a vector database. And the idea behind a vector database is that it stores, indexes, searches across large quantities of these things called embedding vectors. And for most people who are familiar with machine learning, I imagine you will know what an embedding is. But the idea is that you have these machine learning models, and if you take an intermediate representation, that is generally a great way to capture all the semantic information of your input. So if I were, for example, to take an image classification model, I have an image that goes through that model, and I take one of the outputs of one of the layers called an embedding. That would be a great way for me to represent that input image. With Milvus and with the community that we had built around it, where at Zilliz, we had a lot of folks come and say, hey, we're really interested in using a vector database. We're really interested in being able to search across all of our unstructured data, so images, video, audio, text, but we don't necessarily have the bandwidth or the capabilities to generate these embeddings ourselves. We don't really have a lot of machine learning engineers internally, or we don't have a lot of MLOps engineers internally either. So that's really where Towhee was born. That's how Towhee came to be. Is we had these users who, they wanted to have greater flexibility in the entire embedding generation process. Towhee nowadays, the way we frame it is that it is a vector data ETL tool. Now, I think it'll sort of become a little bit clearer as we chat about Towhee during this session. But the idea is that we want to be able to turn all sorts of different types of data into vectors and to be able to index them in a vector database. And that ranges from everything from images to natural language, text to some of your lesser known data types as well. So geospatial data, for example, map data. You have IoT data streams, sensors, from sensors, out in the field, 3D molecular structures, so on and so forth. And we want to be able to turn all sorts of different types of data into an embedding. That's what Towhee is really all about.
And so as far as the Milvus project, I'll add a link in the show notes to that, as well as the data engineering podcast interview we did on that for people who want to dig deeper into that aspect of it. And as far as the question of vector embeddings and their role in machine learning, you talked a little bit about that, but I'm wondering if you can talk to some of the different tasks that are involved in being able to actually take some source piece of data and generate a vector embedding from it, and some of the pieces that are most challenging or generate the most toil and kind of boilerplate effort.
I think when most folks think about embedding generation, they like to think of it as just a one-step process. So if I have an image, for example, I'm a computer vision guy, so I always like to go back to the example of image processing. If I have an image, for example, I just throw that into my machine learning model. I throw that into my computer vision model, transformer-based, VIT or, clip or something like that. And boom, just snap my fingers, out comes my embedding. And, for the most part, sure, that might be true. But when we are looking at other data types as well, when we are looking at, let's say, videos, for example, oftentimes there are many ways that we can generate those embeddings. If you were to look at some of the older 3D convolution, the video embedding models based on 3D convolution, those are really more of a one-shot embedding generation technique. There's also ways where you can do it frame by frame, or you can chop up a video into, let's say, 10 frame segments and generate embeddings based off of those. And then maybe we have some sort of summarization algorithm or a summarization model later on, which will turn all of those into a single, maybe larger embedding. Or perhaps we just concatenate the embeddings from all of these individual frames. That's also another possibility, right? So oftentimes when I sort of give this particular example, I think it becomes clear to folks what some of the main challenges in embedded generation are, which is that it's not necessarily, in many cases it is, but in a lot of others, it's not necessarily just a single step. I can't just take my data, put it into a machine learning model, and then get an embedding, right? And when you combine multiple different models, or when you combine multiple different steps, you can end up having a lot of application level code that can be hard to debug. You have, these models and these embeddings, these floating point vectors flying around everywhere. And having a way to describe those in a data pipeline or a vector data ETL pipeline is important to a lot of the folks that we spoke to within the Milvus community. And, these days, Towhee has been able to form a community of its own as well, which, I'm really quite happy about. Tobias, so going back to your original question, that is one of the greatest challenges with vector data ETL today. And on top of that, I also want to mention that not every embedding generation technique uses machine learning. So there are examples, there are forms of embedding generation that, for example, are more based on handcrafted algorithms. They're more about taking a piece of data that I have and running that through an algorithm that I've developed internally to be able to get, a vector or a tensor out of that. And a great example that I like to give is when it comes to fraud detection or when it comes to antivirus and cybersecurity in general. One of the ways that we can represent executables or APKs is actually by looking at some of the different features of that APK. So for example, how many times does it look up files in the file system? How much memory does it use and when? How many network calls does that particular executable make? And when you put all of these into a vector, that also is, in some way, shape, or form, an embedding. It's a feature vector. So it can also be indexed in a vector database to help you do a semantic search, to help you to do scalable vector search. These days, definitely for sure, most people think of embeddings as something generated from a machine learning model, but absolutely there are other ways to generate these feature vectors as well.
In terms of the utility of vector embeddings, I'm wondering, is that something that is a requirement for the majority of machine learning use cases? And for those instances where you are relying on a vector embedding as an input to a machine learning model, whether for training or inference, what are some of the ways that it's actually used within that machine learning project once you have gone from, I have an image, to here is the vector representation of it?
When it comes specifically to the idea of a vector database and the greater vector database ecosystem, absolutely the main sort of applications that you see are in semantic search, in vector search, or understanding what we like to call unstructured data. Data that you can pass through machine learning models or data that you can pass through your own handcrafted algorithms to be able to get an embedding based off of that. But embeddings, the way that I like to think of them is that they are the language of computers. So we, for example, right now we use English, but there are multiple different human languages out there as well. There's French, German, Swahili, Mandarin, Japanese, so on and so forth. And the way that I like to think about it is that every machine learning model that we have, really, it is a way for computers to express themselves, a way for machines to express themselves. And with this idea, I think it becomes clear that embeddings are used it becomes clear to see why embeddings are used in a wide variety of applications. So, even though embeddings are originally from, the concept of encoders, the concept of autoencoders, where I take an input, distill it into a latent space, and then I try to recreate that input. These days, embeddings are essentially any way to represent my input data as a vector. And with that power, we are able to actually use embeddings, not just in, let's say, semantic search, but also in other machine learning models, also in a variety of other applications as well. So diffusion models, I think, are a great example of this, where essentially each step of a diffusion model, diffusion models are based off of thermodynamics, but each individual step of a diffusion model, you're essentially distilling information down at each step and being able to have these different vector representations.
And then as far as the form that the vector representation takes for a given input, are there any considerations that need to be made about how that vector is structured and the types of information that you are encoding into that vector representation, particularly in the context of how you're actually going to consume and manipulate that vector representation within that model, whether for training or inference?
Yeah, I think it's always important to understand the limitations of an embedding are not necessarily related to, well, in some way, shape, or form they are, but the strength of your embedding is very much primarily limited by the input data, by your training data. And, if I'm only training a machine learning model to, let's say, recognize the difference between cats and dogs, I try to extend it to be able to recognize the difference between, let's say, pigeons and geese. That's probably not going to work, right? My embeddings aren't going to be powerful enough to be able to distinguish between other animals aside from cats and dogs. So A lot of the limitations of embeddings are really some of the limitations that you would see in the training process itself, right? So if you had these models that were only good for a particular task, you'd want to apply those embeddings for that same task as well. You wouldn't want to try to, have an embedding be a distillation of data from another domain.
Another interesting element is the consistency of a vector representation. If you are using one approach for being able to take an image and encode it into its RGB channels, and that's what you're training your machine learning model, and then in the inference stage, maybe the machine learning model was developed so that it's actually using, HSL instead of RGB for, the individual pixels. What are some of the risks or pitfalls that you need to be considerate of when you're building the model, both from the training and the inference side, for how you are able to kind of validate that the information being encoded into those vectors is semantically compatible, and also some of the challenges of being able to manage some of the kind of evolution of that. I don't know if schema is the right word for it, but the way that the vector is representing the information.
Yeah, absolutely. That's a great question. And it sort of ties back into why we started the Towhee project to begin with as well. Again, I'm going to go back to the example of computer vision, where if you have an image and I've trained it in a particular way, I want to make sure that inference is done in the exact same way as well. And a great example of that is if I, let's say, train a computer vision model and it takes, let's say, 224 by 224 input images, or 256 by 256, whatever you like. And I have these very large images and I want to downsize them so I can train them in the model itself, in the embedding model. Oftentimes, I would probably need to use bicubic interpolation, or maybe I use nearest neighbor interpolation to downsize these images. And a huge pitfall that I see is that folks, when they take a computer vision model, they don't necessarily see, or they don't necessarily understand how it was trained with, the data that it was trained on, or how it was trained to begin with. So if I train, an embedding model with bicubic interpolation, during inference, I would also want to use bicubic interpolation as well. And this sort of ties back into why we developed Towhee to begin with, which is that we want to be able to abstract away all of these transformations, and we want to be able to abstract away all of these pitfalls into this vector data ETL pipeline to make that a lot more accessible, not just for machine learning engineers, but also for general software engineers as well.
In terms of the Towhee project itself, can you talk through some of the implementation of it and the utilities that it provides to engineers who are trying to manage the embedding representation for their ML projects?
So Towhee, really, we tried to build it around this definition of vector data ETL. And to do that, I think the first place that we started is with the descriptive layers, with the user-facing layers. So essentially, when you think of ETL, you think of multiple different steps to get the result that you want. And for Towhee, the input, going from input all the way to output, we define it as a data pipeline. So the topmost user-facing layer, and again, I wish I had a whiteboard where I could draw this out, but the topmost user-facing layer, the descriptive layer, is sort of like a Spark-like language where you can describe your pipeline just by chaining different functions or different operations together. So that's the descriptive layer, right? And once we have that, once the user describes the pipeline, and it can just be in a single line of code for sure, once you describe the pipeline, that will then get sent to, in Towhee, we have a planning layer. And the planning layer, essentially what it will do is it will say, okay, maybe you want to run this either on the cloud, or you want to run this locally, or you want to run it in your local server that's got a huge bank of GPUs. All of that, it will figure out the best way to execute this particular pipeline with compute resources that you have. And then once you have all that planned out, it will then get sent to the execution layer, which will actually do the computation. And the reason why we architected it like this is because we want folks to be able to use Towhee to prototype these vector data ETL pipelines, but also to be able to eventually put them into production as well. our hope is for users to go all the way from prototyping to POC all the way to production with a single library. I think that's really one of the unique features of Towhee, and it's one of the reasons why we focused on vector data itself rather than focusing on the broader machine learning world, rather than focusing on the multiple different types of things that you can do with machine learning models.
Another interesting element of this project is that, as you said, it is a framework for building these ETL pipelines focused specifically on vector embeddings as the output. And most of the time when you hear ETL, you're thinking, okay, that's the job of the data engineer. And we're on an ML podcast. So I'm wondering if you can talk to who you see as the person who's actually going to bring Towhee into an organization, who is going to build and own at least the initial work of designing these pipelines and implementing the pipelines, and what you see as the crossover point from Towhee as a machine learning tool to Towhee as a data engineering tool.
For me in particular, and I know, the rest of the team, many of the folks on the rest of the team feel this way as well, machine learning is becoming so ubiquitous that it is becoming a part of data engineering, that is becoming part of our data pipelines. And the reason I think, why this, again, this also ties in with why we started the Towhee project. But with machine learning becoming a part of data pipelines, with machine learning becoming, part of organizations, big, all the way from small startups, 10-person startups, enormous tech companies, it becomes important for us to try to understand machine learning not as some out of this earth, some totally crazy, wacky thing, but a tool that we can use on an everyday basis. And yeah, of course, I think, Tobias, you were mentioning that this traditionally is a domain of, let's say, data engineers. But with Towhee, our hope is that it can be more accessible, machine learning and in particular, embedding models and vector data can be more accessible not just to these data engineers, but also to regular software engineers as well. So maybe I'm a backend engineer, but I want to be able to create this vector data ETL pipeline. I don't have too much knowledge about machine learning, or I don't have too much knowledge about all the different data transformations that need to be done in order to have a successful AI application. I can use Towhee to be able to not necessarily abstract all of it, but abstract some of that away. That's really our hope for what Towhee can be.
Another aspect of it is that if you are a data scientist or an ML engineer and you're iterating on the model and you're experimenting with the data that you have, you're trying to build your training data set as kind of your initial proof of concept, most of the operations that you're trying to build into Towhee are just going to end up scattered throughout a Jupyter notebook, hopefully set up in a way that you can actually do it more than once. And then most of the time, that notebook is then going to be handed to a data engineer to say, okay, here's what happened. Please turn this into a pipeline so that we can build this ML model and put it into production.
Exactly. And we've actually seen a lot of those where we were talking with folks originally from the Windows community, and they'd be like, I have these data scientists, they give me this Jupyter notebook and tell me to put it into production, or they give me this script and they tell me to put it into production. I have no idea where to start. That's a lot of the feedback that we get as well. It's actually great that you pointed that out. And it's definitely one of the critical problems that we hope to solve with Towhee as well.
Yeah, and I think that one of the main points of value that comes out of a project like Towhee is that it allows you to have this shared vocabulary about what is actually happening, where if you leave it up to an individual to build their own approach to writing a script that does all the pieces that they want, they're going to use the terminology that makes sense to them, and then somebody else might come in and use slightly different terminology to do the exact same set of operations. And so as somebody who's working with the ML team, either as a developer or a data engineer or a data analyst or a business owner, they're going to see these two different things and think that they're completely different, whereas actually they're the same thing. And so if you have this library or catalog of operations where you can say, I'm going to do this one step, as long as that one step does what you need it to do, you can just chain it together. Everybody's going to be able to coalesce around a single understanding of what's actually happening without having to try and kind of remap their semantic understanding of the world onto the specific set of operations.
Yeah, that's actually a great point. And I personally hadn't thought of that, sort of using Towhee as not necessarily a single source of truth, but a way to communicate what my data pipeline is doing or what I am trying to accomplish with this vector data ETL or with this particular data processing pipeline. That's actually a great point. This is definitely something that we'll sort of keep in mind as we reach out to folks in the community as well. Yeah, thank you for that.
Absolutely. And on that line, too, I'm wondering what your approach has been to figuring out how to design the interface and the API to Towhee so that it is understandable and accessible for people who are coming from those different backgrounds, where maybe I'm working in computer vision, or maybe I'm working in natural language processing, or I'm a data engineer who's working with ML engineers, being able to build the framework in such a way that everybody can orient around it and be able to actually know what each person is doing and what the different stages of the pipeline are supposed to represent.
Yeah, of course. And very early on when we were building Towhee, we've definitely had some changes to the core mentality for what Towhee as an open source project, what it is. And these days, we like to frame Towhee as a way to allow you to rapidly iterate on your applications that require embeddings or your AI applications in general. And if you really think about it from this particular perspective, we definitely want to be able to make Towhee accessible to software engineers. But for folks who have a new model or a new method of turning data into an embedding, or maybe even a multimodal model that encompasses a wide variety of modalities, we want to be able to have their method in Towhee to be able to turn this unstructured data into vectors as well. And we've really been thinking about this process and trying to figure out what the best way to onboard some of these ML model developers, some of these researchers, some of the latest, let's say, papers in CVPR or EMNLP. And I have to admit that we are still working our way around this particular aspect. So how we help, how we bring value to not necessarily just software engineers and data engineers, but also to researchers as well. We've still been trying to figure this aspect out. But I think once we do, I think we'll be in a much better place with Towhee as a project overall. It's one of the questions that, I'd be happy to get your advice on as well, Tobias, and also try to figure out, how do we reach a greater audience and how do we make Towhee more accessible to everybody, not just the folks who would be able to create these data pipelines. But sort of getting back to your original question, these days, I think we definitely have a focus in addition to the user interface. And also we're trying to figure out how to make it a lot more production ready. And, our hope is that once it is, vector databases along with Towhee, vector databases such as Milvus will be a lot more mainstream than they are today. That's our ultimate goal there.
Are you struggling with broken pipelines, stale dashboards, missing data? If this resonates with you, you're not alone. Data engineers struggling with unreliable data need look no further than Monte Carlo, the leading end-to-end data observability platform. Trusted by the teams at Fox, JetBlue, and PagerDuty, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo monitors and alerts for data issues across your data warehouses, data lakes, dbt models, Airflow jobs, and business intelligence tools, reducing time to detection and resolution from weeks to just minutes. Monte Carlo also gives you a holistic picture of data health with automatic end-to-end lineage from ingestion to the BI layer directly out of the box. Start trusting your data with Monte Carlo today. Go to dataengineeringpodcast.com/Monte Carlo to learn more. In the process of building the Towhee framework and the fact that you are dealing with some fairly sophisticated algorithms or pre-trained models, and they're not necessarily going to be stable and deterministic, what are some of the interesting engineering challenges that you've had to address around building a framework that is aimed at being repeatable and reliable?
A big feature or a key feature that a lot of our users were asking for initially is being able to take something from just on my laptop, for example, and being able to turn that into something running in production very, very quickly. I think that's a challenge for a lot of folks in machine learning today or in ML ops as well. And Towhee really morphed originally from being, this sort of graph slash pipeline based library, something that just runs locally and allows you to prototype different machine learning models, to a way to describe your ETL pipelines, your vector data ETL pipelines, and to be able to have that run not just locally, but also let's say in a bank of servers that you have running on the cloud or running on-prem. And there's a lot of great projects out there that are very much targeted towards small scale use cases. And by all means, I have a lot of respect for those as well. But for Towhee, the workflow that we're really targeting is to rapidly iterate your pipeline to be able to try out a variety of different models. Going back to the image embedding example, if I'm doing an image embedding pipeline, to be able to try maybe transformer-based models, confident models, hybrid models, all the way up to ensemble models, get the embeddings from them, and to be able to run them to be able to, let's say, store them in a vector database and to query them in a vector database as well. We are trying to smooth out this entire process from start to finish. We're trying to make it much more accessible to a lot of our user base. We're trying to tackle everything from what you would do locally all the way to what you would then do maybe in a small scale production on a single machine, all the way to something large scale in the cloud.
As far as the optimizations that are required for being able to make this something that people actually want to use instead of making it a chore to use, where you say, okay, I'm going to run this pipeline and now I'm going to go and drink a couple of pots of coffee while I wait for it to complete versus now I'm going to trigger this pipeline and okay, it's done in, the next 5 minutes. What are some of the aspects of kind of optimization, both in terms of the developer productivity, but also in terms of the processing capabilities that you've had to invest in?
This also sort of ties back into the 3 layers, the Towhee framework that I was talking about, where we have the descriptive layer called data collection, we have the planning layer, and then the execution layer. And a lot of our optimizations actually primarily revolve around execution. So, looking at the workflow of, let's say, a data engineer, a software engineer, or even a machine learning engineer, where you want to be able to take something locally from your laptop in an IPython notebook or in a Python script all the way to production, thinking in that particular context, maybe at a small scale when we're really only testing our embedding pipeline or we're testing our embedding-based application, we don't necessarily care too much about how quickly it runs. Maybe we only have a very small amount of data, let's say 10,000 samples or 100,000 samples, and I want to be able to see how it works on a small amount of data, before I then deploy it into production. And that's really why a lot of our optimizations that we've incorporated into Towhee, why they revolve around the execution layer. So, for example, once we have a graph, a DAG, out of the planning layer, we do graph optimization. So any redundant operations, any redundant transformations, we'll make sure to sort of squeeze those into a single operation. For any model-based operators in the entire pipeline, we will do auto batching. So they're obviously on GPUs, it's oftentimes better to be able to batch many images or batch many inputs and to be able to have them all run together. And then, also figuring out, this is one of the really cool things about Towhee, figuring out what runs best on the CPU versus the GPU versus an accelerator. Which operators or which operations in my pipeline should I put on different machines or on different pieces of hardware. That's something that Towhee does automatically as well. It's something that's still in development on our end. It's obviously not perfect at this point, but it's one of the cool things that Towhee does, and Towhee will continue to do better in the future as well.
In terms of the developer experience of using Towhee, what's the process for being able to actually get it set up, incorporate it into the model development, model training workflow, and then going from prototype into actually deploying Towhee as a component of their production ETL pipeline so that it's actually running on a regular cadence?
When it comes to Towhee as an ETL pipeline, I think it really depends strongly on the application itself. Oftentimes, there are applications where you would want to be able to stream data in. So if you have a B2C application, for example, you have, let's say, many, many new documents or images or pieces of unstructured data uploaded per day. Having Towhee run on a single machine or even in a cluster of machines and having that scale up and down dynamically is probably a very important component of your embedding-based application. And then there are others as well where maybe all I want to do is I already have this huge bank of data. For example, if I have these 3D molecular structures, I have a fixed number of them. I want to be able to compute embeddings across all of those and then be done with it. Maybe I don't necessarily need to run it on an hourly basis or on a daily basis, or I don't necessarily need to run it in real time. And the approaches that different users or different applications would take for different types of tasks, actually, we try to minimize the variance between those when it comes to Towhee. We try to make it so that Towhee can target a wide variety of applications and to not really have to utilize all the compute resources in the world when doing this. I'm not sure if this really answers your question too well, but a huge consideration when it comes to volume or when it comes to complexity of data that our users are processing is definitely key for us. We want to make sure that in addition to being able to run something locally, they can also scale a pipeline horizontally across many machines. If they have a machine that primarily is, let's say it's just a bank of GPUs versus, maybe they have another set of machines that are primarily CPUs and they have others where they implement other accelerators, we want to be able to understand what is the best and most efficient way to run a vector data ETL pipeline on these bank of machines. That's one of the challenges that Towhee tries to tackle there.
In terms of the scaling of Towhee, where if you're experimenting with it, you just want to get a feel for what does this do for me? How do I use this for my ML project? To, okay, now I want to actually put this into production where instead of dealing with 5 or several dozen images, I now want to deal with several thousand or hundreds of thousands of images. What are some of the scaling considerations involved in both the volume and also the variety of data that you're working with?
When you're talking about scaling, generally there are, not exactly true, but I would say generally there are two different ways that you can scale, vertically and horizontally. And obviously, when you do scale something vertically, there's always a limitation. So there's, for example, a limitation to the number of accelerators or number of GPUs that I can fit into a particular machine. But when I am scaling horizontally, when I'm scaling something across a cluster, across 10 or 100 machines, I'm scaling my pipeline across these, then you sort of run into the challenges that I was alluding to earlier, where how do I run my ETL pipeline across machines in the most efficient way possible? How do I assign operations to each machine in order to be able to utilize that machine's resources to the best of their ability? So, let's say I have these different types of machines running in my cluster. I probably would not want reading a document. I wouldn't want that to be done in a machine that that has a very powerful GPU or a very powerful accelerator in it. I probably want that to be done in a machine, that probably has a server CPU or, some other bank of processors, right? And figuring these out and abstracting a lot of these operations away from the user, this is something that we try to do long-term with Towhee. We do have a version of this right now, a version of this sort of automatic placement right now, but it's definitely not perfect, and it's definitely something that we can improve on in the future.
Another interesting element of Towhee is that you have a built-in library of different embeddings and types of data that you're able to work with. And I'm wondering if you can talk to the interfaces that are available for being able to integrate with Towhee from a kind of tooling and platform perspective, but also ways that teams are able to extend Towhee and add new capabilities to it.
With Towhee, I think a lot of that would come into, a lot of that is really up to the user and how they want to be able to implement their pipeline in the descriptive layer. And if you have, let's say, a new operation or a new operator that you want to be able to run in a Towhee pipeline, or in a vector data ETL pipeline, we try to have these very atomic units of work called operators. And I sort of talked about it a little bit earlier, but I didn't really describe what each of those are. An operator is a single unit of work, and it can be, some examples of different operators that we have built into Towhee or as a part of the Towhee hub are, for example, image loading, image transformation. A single machine learning model could also be considered a single operator. Video decoding is an operator. Text embedding is also an operator there as well. And if, let's say, I am a data engineer or machine learning engineer, and I've created this new embedding model, or I've created this new embedding algorithm, Towhee provides an easy way to wrap that in an operator and contribute that. If you want to have like a local version of the Towhee hub running internally, or if you want to contribute that to the greater Towhee hub, or the central Towhee hub that's freely available to everybody as well, those are both possibilities. And I would say that's really the primary way for users to extend and integrate what they have right now with the broader Towhee ecosystem, is through these operators. Once these operators are part of the central repository that, again, we call a hub, then your software engineers and your data engineers, they can freely use these operators, they can use these operations and chain them together really in just a single line of code to be able to prototype, to be able to deploy these vector data ETL pipelines. So yeah, I'm glad you asked that question. And to really sum it all up, I think a lot of the integration, a lot of the interfacing that we do with Towhee is done through these operations, done through these atomic units of work.
With the kind of shared utility of being able to say, okay, I have this pipeline, I'm able to share this workflow with the other engineers on my team or the data scientists. We don't have to rewrite the same script, 30 times because we want to do different iterations either on this one model or different models. How does that have a broader impact on the types of models that teams are able to build, the way that they approach model development, just general kind of capacity and throughput, and their approach to machine learning more broadly?
What we really want to be able to do is, let's say when I have this really established vector data ETL pipeline, and it's composed of all these individual operators. And perhaps one of these operators is, as you mentioned, an ML model, or it is a computer vision model, or really anything, right? As a data scientist or as a machine learning engineer, if I make an update to one of these, or if I push it and I want to be able to tell the software engineers, I want to be able to tell the DevOps or MLOps folks to do an A/B test to see if it works better in production, that is something that can easily be done. It's essentially just redefining one particular operator in the pipeline. And as I mentioned earlier, we do have this descriptive layer in Towhee, which is essentially this method chaining API where you can chain different operators together just by doing a function call. And if you think about it, now if I'm a machine learning engineer or a data scientist or a research engineer or a research scientist, and I've updated this model, I can then push that to the hub and very easily or very rapidly iterate on that if I am on the DevOps side. Just simply update the operator, the name of the operator itself, and now I have two different pipelines, an old one and a new one, that I can compare in my test environment to see if it works or to see if it makes my results better. That's really one of the core ways that we hope users will be able to use Towhee, even for ourselves when we are looking at different ways to develop these applications, or different ways to help our customers utilize embeddings and utilize a vector database. These are one of the ways that we do it ourselves as well.
As somebody who is working on the Towhee project and working on the Milvus database for being able to store the outputs of Towhee, what are some of the ways that you're actually using Towhee in your own work and some of the insights that that's able to provide for how you want to evolve the framework going forward?
For Towhee right now, we have, as I was mentioning earlier, it's really composed of these atomic units called operators. And going back to the idea that if I want to create an embedding application, or if I want to create this vector data application, It's never just a single model. And these days, we've extended Towhee to be able to insert into vector databases such as Milvus and to be able to query across vector databases such as Milvus as well. And what we are really trying to do there is to say, in addition to the ETL side of things, in addition to just generating the embeddings, we also want you to be able to prototype the application as well. And we also want folks to be able to take this vector data and to push it to maybe other machine learning databases, maybe push it to feature stores, or maybe have this embedding used somewhere in Snowflake, for example. I'm probably getting a little bit ahead of myself here, but that's really the future of where we see Towhee, as an open source project. Is we want to be able to define entire applications and entire ways of developing applications that use embeddings and that use these vector data. Right now, for sure, we're sticking to the idea that it is a vector data ETL tool or a vector data ETL pipeline. But later on, I think as we evolve, and for us internally, as we, especially since Towhee grew out of a vector database or grew out of Milvus, which is a vector database project, we want to be able to interface with more of, quote unquote, the outside world. Not just say, here's your unstructured data, throw that into Towhee, and then here's your embeddings, and that's it, right? We want to make the application development process smoother as well, and not just the ETL process.
In your work of building Towhee, using it for your own projects and collaborating with the community, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
It's actually very interesting. We had one of our users sort of come to us directly and say, I want to do time series embedding and time series prediction with Towhee. Just on the surface, it doesn't sound too sexy, but what this user was trying to do was they were trying to predict the stock market with Towhee. They had these different time series models, but it was becoming a bit of a headache for them to keep track of all of them. It was becoming a bit of a headache for them to understand, okay, how do each of these models change the predictive results of the pipeline? With Towhee, they actually ended up building a pipeline. They hadn't even thought of Towhee in this particular use case, but they had these time series embedding models, and they were actually doing visualizations with Towhee. So the output of Towhee was actually not necessarily just an embedding, but it was a visualization as well of saying, okay, this for this particular period of time, this is how my particular time series model did compared to how the stock market actually performed. I am not sure if this particular user, if they ended up putting this into production. I would love to see if they did, but it was definitely one of the more unique use cases. So stock market prediction and really visualizing, these time series models, how they performed relative to how the stock market actually performed.
And so for people who are working in the ML space and they're dealing with vector embeddings, they're trying to transform their unstructured source data into some representation that they can feed into their models. What are the cases where Towhee is the wrong choice?
I will say, so, we've spent quite a bit of time talking about what Towhee is, and I will say what Towhee is not, right? Towhee is not meant to be an all-in-one MLOps platform. We do have a fine tuner in Towhee, so you can take a model and you can fine tune it on your own data. But quite a bit of the training process and really understanding how your model performs, a lot of the stuff that the folks at Weights and Biases do, that's really not a part of Towhee. It's not meant to be an all-in-one MLOps platform. At least for the time being, it's not meant to work for applications that don't require vector data or applications that don't require embeddings. With Towhee, we're trying to reimagine the ETL process as something that includes machine learning within ETL, as something that includes machine learning in the transformation step. You see a lot of traditional ETL pipelines. They might be how they're using Snowflake or other data processing platforms, for example. They're more used in the context of, let's say, SQL, or to transform data from a source that might be a little bit noisy or a little bit messy into something a little bit more cleaner or organic. And all Towhee is really trying to do is reimagine that process, but with machine learning in the middle. And when you do have machine learning, when you're able to use embeddings, as I was mentioning earlier, as I alluded to earlier, the language of computers, that's really the primary mission that Towhee is trying to accomplish. Towhee is definitely not the right choice for if you're trying to build a complete, MLOps solution from end to end, for example. If you're trying to train these new huge models, if you're trying to train these large language models, if you're trying to, let's say, understand or do model visualizations, Towhee is also probably not the right choice for you. But if you already have a model that you want to put into production, an embedding model that you want to put into production, that you want to test, you want to create a POC out of it, and then you want to put that POC then into production, that is where Towhee, I think, can really help speed up development. That's really what Towhee excels at, and that's really where I think Towhee would shine.
As you continue to build and work on Towhee and evolve it, what are some of the things you have planned for the near to medium term?
For Towhee, we plan to continue making optimizations primarily to the execution layer. I was talking about earlier some of the optimizations that we can have to, let's say, put operations that require more compute on a GPU, on an accelerator, put operations that are a little bit more data bound on the CPU. And we will continue to improve on that particular aspect of Towhee. And a big thing for us is also really trying to get the message out about vector data ETL, and about how we can use machine learning in the ETL process itself, and not just as this really cool or this really out of this world thing that only machine learning engineers know what they're doing, or only data scientists know what they're doing. And if I'm a software engineer, the only thing I can do is take the script or take the model that they provided for me and figure out a way to scale that horizontally. We're really trying to make Towhee, have it be something that really tries to make embeddings and vector data in general, make it more mainstream.
For anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest barrier to adoption for machine learning today.
Even though machine learning has progressed, so significantly in the past 5, 6, 7 years, I think having more folks understand machine learning, not necessarily from a black box perspective, but really understand that today versus machine learning, many years ago, is a lot more mature and is a lot more systematic, and we have a much better understanding of how these models work and some of their limitations, and particularly when it comes to embeddings, where we should and where we shouldn't use them. So we're really trying to send this message where machine learning, more and more folks are becoming comfortable having them in production, and we want to be able to make specifically the vector data part of it accessible to a lot more people.
Thank you very much for taking the time today to join me and share the work that you're doing at Towhee and sharing your experience and insight on this space of vector representations of unstructured data and the role that it plays in the ML ecosystem. So I appreciate all of the time and energy that you and your fellow maintainers are putting into Towhee to make this a more tractable problem, and one that people don't have to spend as much of their time rebuilding the same thing. So thank you again for all the time and energy you're putting into that, and I hope you enjoy the rest of your day.
Same to you. Thanks for having me on the show, Tobias.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.